I am treating one of the difficult courses in chemistry as far as secondary school curriculum is concerned, and that is the gas laws. You know how tough students find Charles' law, Boyle's law, general gas law, ideal gas equation, Graham's law of diffusion, Dalton's law of partial pressure, and so on and so forth. This video is actually the introduction to gas laws. But before I continue, if this is your first time of seeing this channel, click on like, share the video, follow this page, and subscribe to our YouTube channel. The gas laws are laws that guide the behavior of gases. Now, before we delve into gas laws properly, there are 5 postulates that you have to memorize. You don't joke with them. They actually form a foundation to the knowledge of behaviors of gases, and they are called the kinetic theory of gases. Now, when you are asked to state the kinetic theory of gases, you have been asked to state the 5 postulates of the kinetic theory. They are 5 in number, and remember, you must have them at the back of your mind. You have to say them as if they are catechism. Now, let me begin with the first postulate. Number 1, gas is made up of tiny particles known as molecules, which move randomly in straight lines, colliding with one another and with the walls of their container. Now, what do we make out of this theory? Number 1, the theory is saying that anywhere you see a gas, it is already existing in a container. Your mind may be going to air. You know, what of air? Is air existing in a container? Yes. Air, or what we call atmosphere, is already existing in container. And that container is called the universe. Right? So what this first postulate is trying to let us know is that all gases are made up of tiny particles known as molecules. And these molecules don't stay at a place. They have what is called entropy. And the entropy keeps increasing. Entropy means the degree of disarray of particles. So this entropy keeps increasing, making them to continually move in straight lines, but colliding with one another. When 2 gases collide, they bounce back. They can collide with the container and bounce back. And that is just what the first postulate is talking about, right? The second postulate of kinetic theory of gases is actually an inspiration from the first postulate. There is a particular idea in the first postulate that was used to develop the second postulate. And that idea is what? Collision. If something is elastic, if you stretch it and allow it, it will return to its original state. That is elasticity. Now, the second postulate states that the collision, that is jamming together of gas molecules, is elastic. When you are running and somebody is running towards you and 2 of you jam head on together, what happens? Automatically, the speed at which you people are running will reduce. Two of you will lose energy. That is why the collision is not elastic. But elastic collision is a collision after which energy is not lost. That is, when 2 gases jam themselves, they go back with the same speed and energy at which they were coming. They just jam, bah, and go back. When they jam the wall, they go back with the same speed. No drop in speed, no drop in quantity of heat, no drop in energy, and that is the second postulate, a definition of elastic collision as the reality of gas molecules. I hope you are following. Now, the third postulate of kinetic theory of gases talks about the volume of that container they are existing in and its relationship with the actual volume of a gas. This is the container of the gas. Let's assume that the gas molecules are 5 in number and they are moving continually in straight line, colliding with one another and with the walls of the container. What the third postulate is saying is that in this container they are equally spread. They are found everywhere, occupying the whole volume, while they themselves have their own volume. This is the actual volume of gas molecules, and the rest plus the actual volume of gas molecules is the volume of container. So what the third postulate is saying is that the volume of gas molecules themselves, when you are considering the gas molecules, if they are to be brought together, they have their own volume. This particular volume is negligible when compared to the actual volume of the container. In other words, gases just assume the volume of any container they are confined in. They don't assume their own volume. They don't say, because my volume is too small, let me come to one corner of the container and stay. In fact, this is the behavior of human beings. If you bring 5 people into a hall, they will go to one corner of the hall and stay, to tell you that they cannot be everywhere in the hall. This behavior is what gases cannot do. If you bring small gas into a large hall, the gas molecules will want to be in all parts of the hall. That is why if you release a perfume at one end of a big hall, the people at the other end will start perceiving the odor just with time, meaning that the molecules of the perfume are able to spread. So the third postulate is saying that the actual volume of gases, when compared to the volume of their container, is quite negligible. Their volume is quite infinitesimally negligible when compared to the volume of their container. I hope you understand that. The fourth postulate talks about the intermolecular force of attraction between these gas molecules confined in a container. As you have gases inside a container, there is what is called attractive force between gas molecules. That each of these gas molecules have attractive force. Now, the fourth postulate states that the force of attraction between these gas molecules is infinitesimally negligible. The word infinitesimally negligible means that the force of attraction between gas molecules is too small to quantify, that you have to neglect it and say there is no force of attraction. So the existence of force of attraction has been trashed by the kinetic theory of gases. According to kinetic theory of gases, there is practically no force of attraction. Gases have no attractive force. Maybe that is why the second postulate says that the collision between gas molecules is perfectly elastic. Because if there is actually a force of attraction between two gas molecules and they eventually collide, that force of attraction would have made the collision to become inelastic, or made the two molecules to stick together. But no, the kinetic theory of gases is saying that there is an infinitesimal negligibility of any existence of force of attraction, or that even if the force of attraction exists, that it is statistically insignificant to quantify. I hope you are following. That is the fourth postulate of the kinetic theory. The fifth and the last postulate of the kinetic theory, in fact, is the most important of all the postulates, because this is where the definition of temperature of a gas comes from. Temperature is defined as the average kinetic energy of gas particles. It must not even be gas, liquid particles or solid particles. As far as there is existence of entropy, movement, there is temperature. The fifth postulate states that the average kinetic energies of the molecules of gases is equal to the temperature of the gas. Mathematically, the temperature of the gas inside a container, let's assume that there are two gas molecules, but we know we have trillions, zillions of gas molecules. But let's assume there are two gas molecules in the container, just like this. There are two in number. Now, the temperature of the gas inside is equal to the average kinetic energy of the two. So we have kinetic energy, half mv squared of the first one, right? Plus half mv squared of the second one, divided by how many molecules? 2 molecules. And this is the definition of temperature. Now, to summarize the lecture, the 5 postulates of kinetic theory of gases are stated as follows. Number 1 postulate. Gas is made up of tiny particles known as molecules, which move randomly in straight line, colliding with one another and with the walls of the container. Number 2 postulate. The collision of gas molecules is perfectly elastic. Number 3 postulate. The volume of the gas molecules is negligible when compared to the actual volume of their container. Number 4 postulate. The intermolecular force of attraction between gas molecules is infinitesimally negligible. And number 5. The average kinetic energy of the gas molecules that make up a gas in a container is equal to the temperature of the gas inside the container. I hope you got value. If you did, click on like, comment, share the video, follow the channel, and subscribe to our YouTube channel. Bye.